guide pins in a nitrogen bath with a temperature of minus 198 degrees Celsius. The liquid gas chills the metal pins and makes them contract. The super cold guide pins can be tapped into the flange of the camshaft segment with ease. As they heat up, they expand to give a really firm fit. Guide connections have to be greased and running surfaces oiled. The men then push the camshaft into the 6-meter-long channel, section by section, making sure nothing gets tilted.
That's fine. A bit lower. Then you'll see it coming. Down a bit more.
The initial phase is completed. The guide neck is now in the channel. The men slowly push it in further. Once again, this is precision work. There is zero room for error. Should something tilt, the engine would be blocked.
Up again, up some more. Just hold it like that.
When the 3 segments have been bolted together, the 2 fitters carefully push the unwieldy component through the engine. The camshaft is made of surface-hardened steel and will not be replaced throughout the entire life of the engine. After 2 days, the work at Station 1 is completed. One of the 25 mega diesel engines manufactured here each year is transported to the next station by overhead gantry. The rotary station is even bigger than the first station. Here, fitters will turn and wheel the Colossus several times and even turn it upside down. The crankcase is the biggest component of the mega diesel engine. Now the second biggest is added, the gigantic crankshaft. 6 meters long and weighing 6,000 kilograms, it is the crucial element at the heart of the engine. Operating at full speed, the heavy crankshaft will rotate at a staggering 20 revolutions per second. For installation of the crankshaft, the engine has to be turned upside down. The fitters wheel the cage. Suspended from the overhead gantry, the huge shaft now moves towards the crankcase. Once again, every millimeter counts. Very slowly, 6 tons of high-grade metal are approaching the interior of the engine. If the component were to slew, irreparable damage would be caused. After 20 minutes, the difficult task is completed. The fitters now turn the huge frame a few more degrees to gain better access to the engine's inlets. Over the next few hours, they will install 20 of these cylinder pistons. Later, the entire combustion process will take place in the power units, as they are known. Each power unit has a capacity of 17.5 liters and is basically an independent single-cylinder engine. The workshop also contains the pre-assembly site for the power units. Before assembly of the cylinders can get underway, the huge connecting rods have to be measured.
This includes measuring the bearing shells, because if the bearing shells are too small, this could damage the crankshaft. All the measurements are recorded exactly to ensure precise positioning.
Then the work can begin. The fitters first prepare the pistons, each of which has a diameter of 27 centimeters. Weighing 100 kilograms, each conrod can only be moved with a crane. The conrod is carefully lowered into the piston. The retaining bolt is then slid into place. It takes a quarter of an hour to install the first of 20 pistons. Next, the focus is on the complex cylinder head. On the rotary table, the fitter inserts 4 bolts and secures the cylinder liner with another 24 bolts. To guarantee precision, they are tightened automatically by a machine.
The process is fully automated and monitored to ensure that I haven't forgotten a bolt and that every bolt has the right torque.
The computer determines the next operation and